this is the compound interest formula. A equals to P times parenthesis 1 plus R divided by M, and then raised to m times t, and then A is the accumulated amount after t years, so which is called the final amount. So let's say you are trying to make a deposit to the bank. So let's say today you deposit $1,000 to the bank, then that $1,000 is your P, which is equals to deposit. Some textbook call that initial amount. So you deposit $1,000 to your bank today, and then let's say 20 years later with some interest rate, and then you are trying to find out how much you will get in 20 years. So 20 years later, the amount that you are getting from the bank is called A, which is the accumulated amount after t years, or you can just simply call that final amount. So initial is your principal deposit. You are putting some money to the bank today, and then many years later, you will get your principal deposit with the interest. So that is called the accumulated amount. And then since we are talking about interest, so we have R is the interest rate, and then T is the number of years, and then M is the number of times interest applied per period. I want to emphasize that some textbook use M and then some textbook use N. And then, so what does that mean? The number of times interest applied. So let's say they calculate the interest semi-annually. So since two semi-years in 1 year, so there are 2 half years in 1 year, right? So that's why M is equals to 2. So there are 12 months in a year, so that's why monthly is M equals to 12. And then there are 4 quarters in a year, so that's why M is equals to 4. And then if they decide to compound the interest daily, then M is equals to 365. You have to be careful that some textbook they use the M equals to 365, and some textbook, I know some accounting, they use M equals to 360. I still remember that when I was earning my industrial engineering degree, I took a class called Financial Mathematics for Engineers. In that textbook, I remember that they don't use M, they use N, the number of compounding per year, and then for the daily, they use 360 days. So some textbook use 365, some textbook use 360. So you have to check to see which number they prefer. So we have the formula. Let's do some examples. So the example that I am going to do is based on this. P is equals to $2,500. So I am going to put this amount to the bank today, and then the interest rate is 4%, and then I'm going to put this money in the bank for 10 years. Now, the first question that I am asking is, let's say I'm trying to compound the interest annually. I would like to compound the interest annually. So let's use a different color to divide this up. So let's say for annually, what is M equals to? I want to compound the interest, calculate the interest annually. So how many 1 year in a year? The answer is 1, right? So M is equals to 1, and then we have A, which is the amount that I will be getting after 1 year. So that is equals to my principal deposit, and then times 1 plus R. R is 0.04 divided by M. M is equals to 1, and then M is equals to 1, and then I'm going to put that in the bank for 10 years. And then you put this to your calculator, you will get approximation. So for the approximation, I will just keep 2 decimal places. So this is approximately equals to this amount, 0.61. So this is my principal deposit plus the interest. If you want to calculate, so how much interest did you earn in the past 10 years? So here is how. So the interest is equals to the final amount, subtract your principal deposit. So the difference is your interest. Okay, let's do the next one. So let's say I want to compound the interest semi-annually. So every half year, I will compound the interest. So what is M equals to for semi-annually? Let's switch to a different color. So for semi-annually, so there are 2 half years in 1 year, right? So that means M is equals to 2. And then all you have to do is you use the same equation, change the 1 to a 2. So A is equals to 2,500, and then parenthesis 1 plus the interest rate divided by 2, and then raised to 2 times 10. So this is approximately equals to this amount, 3714.87. And then how much interest did you earn in the past 10 years? So here is the interest. That is equals to your final amount. Subtract your principal deposit. So whatever that equals to is the interest you earn in the past 10 years. You might say, that looks a little bit unrealistic. Yes, I'm trying to make the number nice. The reason that you are seeing this is unrealistic is because in real life, the interest is way lower than this. Okay, so we did annually, semi-annually. How about quarter? So let's do a quarter. Quarterly. How many quarters in a year? There are 4 quarters in a year, right? So that means M is equals to 4. So A is equals to your principal deposit, and then 1 plus your interest rate divided by M, and then M times 10 years. So this one, I got 3722.16. So that is the final amount that you will get in after 10 years. And then what's the interest equal to? So the interest is equals to final minus initial, so 3722.16 minus 2500. So that is the interest you earn in the past 10 years. The next one, how about monthly? How many months in a year? The answer is 12. So for monthly, then M is equals to 12. All right, so let's do that. So for monthly, we have M equals to 12. There are 12 months in a year, so A is equals to 2500. And then 1 plus the interest rate divided by 12 raised to 12 times 10. So this one, I did the math already. So this one I have approximately 27.08. Again, we keep 2 decimal places for money. And then what's the interest? The interest is final minus initial. So interest, that is equals to final minus initial. So that's for monthly. How about weekly? How many weeks in a year? Do you know that? How many weeks in a year? The answer is 52. So there are 52 weeks in a year. Which color should I use? Let's use red. So for monthly, we let M equals to 52. There are 52 weeks in 1 year. So A is equals to, so A is equals to 2500, and then 1 plus the interest rate divided by 52 weeks, and then we raise to 52 times 10. So this one I have approximately equals to 3728.99. Let me make sure I got this right. So for quarterly is 3722.16, for monthly 3727.08, and then 3727.99. Because the most dangerous part is I got that right on my calculator. When I copy that over to my paper, I copy the numbers wrong. Okay, interest. So that is equals to final minus initial. So whatever that equals to, that is your interest. And then the last one is daily. How many days in 1 year? Again, some textbook use 356, some textbook use 360. Okay, let's do that. So which color should I use? Let's use orange. So for daily, that is M equals to 365. So we have A equals to 2500, and then 1 plus the interest rate divided by 365, and then 365 times 10 years. Again, some textbook use 360. So this one, I have this approximately equals to 3729.48, and then the interest rate is equals to final 3729.48 minus initial, which is 2500. Now, before we move on to the next problem, I want you to make a comparison. Which method gives me the highest final amount. So for daily, you have a 37.29, and then monthly is 37.28. So the daily is more than monthly, and then if you compare, wait, hold on, weekly, weekly. What did I write? Monthly. So this is supposed to be weekly. So daily is more than weekly, and weekly is more than monthly. Monthly is more than quarterly, right? So if you go back all the way to the beginning, you will see that annually has the smallest amount and daily has the highest amount. Why? Because this number is number is big. The reason is this number is big, the 365, because you have to compound this every day. So that's why the final amount is so large. But let me tell you this: when you do homework problems, homework and exam, they won't make the problem so easy. So let's twist the problem a little bit. So in the next part, what I would like you to do is I would like to give you a final amount and then ask you to find the initial deposit. So let me switch to a different color. So let me move on to the next page, and then before we do that, I would like to go ahead and then paste this formula over here. So we have this formula. So what I am trying to do this time is, let's say I need $5,000 in 15 years. So I need $5,000. So A is equals to 5,000. I need $5,000, and then in 15 years. So starting from today, 15 years later, I would like to have $5,000. So that means T is equals to 15 years. And then the interest rate, let's just make up a number. Let's use nice numbers. So let's say R is equals to 10% interest rate. And then the method that I would like to choose for compounding interest is monthly. So monthly, that means M is equals to 12. There are 12 months in a year. Now, my question is, how much money do I need to put in my bank right now? I need $5,000 in 15 years. So using this interest rate and this compounding method, how much money do I need to put in the bank right now? Okay, so here is how we're going to do this. So we plug in 5,000, and then that is equals to P, and then 1 plus R, 0.10, divided by 12, and then raised to 12 times 15, right? And then as you can see, this piece is a real number. So all you have to do is you take 5,000 divided by that. So P is equals to 5,000 divided by 1 plus interest rate, 10%, divided by 12, and then 12 times 15. I would like to do this in one line. So do you see the first screenshot right over here? I would like to do this in one line because I don't want to do the denominator first, round, and then take the 5,000 minus the round off. So that will just make the number less accurate. So I would like to just do everything in one line. So one lesson that I want you to learn is how to type this on your calculator correctly. So my tips is use parentheses. Okay, don't be lazy. Use parentheses when needed. So this one P is approximately equals to 1122.61, right? So if I want $5,000 in 15 years, I have to put this amount to the bank today. All right. And then the next problem that I would like you to do is I would like you to find the interest rate. Okay, so let me make another problem for you. This problem, how about this? I am going to need $5,000. I need this amount, but I only have $1,000 right now. I need $5,000 in 15 years. So let's say T is equals to 15 years. I have 1,000 right now. 15 years later, I need 5,000. And then the interest rate, we don't know. I don't know what the interest rate is. How about the compounding method? How about quarterly? So let's try a quarterly. So that means M is equals to 4. So T is equals to 15, M equals to 4, A is 5,000, P is 1,000. What is the interest rate? So all you have to do is you plug in first. So this is a 5,000, right? That is equals to 1,000, and then parentheses, 1 plus I don't know the interest rate divided by 4 and then raised to 4 times 15. So the first thing that I would like to do is divide both sides by 1000. So 5000 divided by 1000, that is equals to 5. And then this is 1 plus r divided by 4. 4 times 15 is equals to 60. So now, do you see that we have a r hiding inside the parenthesis? And there is a 60 in the exponent. How do you bring the exponent down? To bring the exponent down, you have to take the log on both sides. So what you are going to do next is, you are going to do ln on both sides. So ln both sides. So when you ln the right hand side, so the left side is ln 5, you can bring the 60 down. So you have a 60, and then ln 1 plus r divided by 4. And then you take the ln 5 divided by ln 60. So ln 5 divided by not ln 60, divided by 60, so that is equals to ln, and then 1 plus r divided by 4. So how do you take the 1 plus r divided by 4 out of the ln parenthesis? So this is in logarithmic form. You have to know that the base of ln is e. So to put this back to exponential form, so here is how you're going to do it. You have to take the e raised to the entire left hand side, so which is ln 5 divided by 60, and then the right hand side is just 1 plus r divided by 4. So the next step is you have to subtract 1 on both sides and then multiply both sides by 4, right? So you have to do e raised to ln 5 divided by 60, you subtract 1 on both sides, and then after that you multiply both sides by 4, so you get an r. So the first challenge is you have to solve for r. The next challenge is you have to know how to input this to your calculator. So I already did it for you. So do you see that in this screenshot, I have a big parenthesis. So I type e and then I type the entire exponents. Do you see that there is an ln 5 in parenthesis divided by 60? You have to use this parenthesis. If you don't use parenthesis, that will be 5 divided by 60. They are not the same. So this is totally wrong. The reason is, if you do not use parentheses, the calculator will perform the division first and then take the ln, which is wrong. You are supposed to ln the 5 first and then divide it by 60. All right, subtract 1 times 4. I did everything in one line. So the round off error is minimized. So what is r equals to? So r is approximately equals to, let's take 4 decimal places, 0.1087, right? So this is approximately 10.87% interest rate, which is not realistic, but I know the point of this exercise is trying to solve for r and use your calculator to evaluate the expression. All right, so that is the end of this video. Do you like it? Is this helpful? If so, give me a like, share, and subscribe, and I will see you all in the next one. Signing out.